Now, let's discuss some sample questions based upon time response of a first order system. Okay, it will be very interesting if you analyze deeply. Okay, so let's get started. First question, unit step response of a first order system with the transfer function C of s divided by R of s is equal to 1 divided by st plus 1. Okay, so the same pattern which we have learned in the theory class. So you don't need to be worried about anything. Unit step response we have seen. So we got C of t as what we got? 1 minus e raised to minus t by tau into u of t. I told you if it is not there, u of t is not there, you can choose that option. If it is there, you have to choose that option. Okay. So in all the options, u of t is not present, so you can exclude that. So here the answer would be first option itself is the correct one. Okay. All other options are wrong. 1 plus e raised to t by tau, 1 minus e raised to t by tau, 1 plus e raised to minus t by tau. So the correct option is 1 minus of e raised to minus t by tau would be the exact unit response of a first order system with the transfer function 1 by s tau plus 1. Next question. A system with the transfer function 1 by ts plus 1, okay, it is given as 1 divided by ts plus 1. Okay, our standard representation. Subjected to a step input takes 10 seconds to reach 50% of step height, the value of t. So a system with the transfer function 1 by t plus 1 subjected to a step input, it is subjected like this. Okay, it takes 10 seconds to cover it up 50% of step height. So which means that if your final value is they are not telling how much value of the magnitude of the final value. So let it be whatever, let it be take 1. So in order to cover 50% means 50% of 1. Okay, that means half value. Whatever final value, half in order to cover half portion, it is taking how many seconds? 10 seconds. This is the meaning of the question. The value of t is. So you know that C of t would be equal to 1 minus e raised to minus t by tau. This is the response which you are going to get when a first order system is subjected for a unit step input. So C of t would be nothing but what? It is given as half, 50% of its step height. So suppose if it is a unit step input, then 50% means nothing but what? In order to cover it up, half portion. 50% would be half. Half is equal to 1 minus e raised to minus t by tau. So e raised to minus t by tau comes left side and this half goes there. 1 minus 1 by half. So 1 divided by e raised to t by tau would get you half. Clear? So you will get e raised to t by tau is equal to 2. Okay? In order to get this, t by tau natural logarithm of e. When you applied logarithm on both sides, you will get the result over here. This would be natural logarithm of 2. Okay. Now, this is nothing but what? Natural logarithm of e would be 1. So, t by tau is equal to natural logarithm of 2 into 2 only. Now, we have to find t. So, t would be equal to total time divided by natural logarithm of 2. That would be time is 10 seconds, natural logarithm by 2. That will be answer would be 14.43 seconds. This will be your answer for the question. So option C will be the right choice for question number 3. Okay. Next question. The unit impulse response of a system having transfer function k divided by s plus a is shown below. The value of a is options t1, t2, 1 by t1 and 1 by t2. Let's see how to do it. We have first it is given transfer function. Your transfer function is nothing but what? K divided by s plus a. Okay, that is nothing but what? Your C of s by R of s. And it says that unit impulse response of a system. So, which means that R of s is nothing but what? 1 only. And then C of t will be Laplace inverse of transfer function, that is nothing but what? K divided by S plus A. You can take K outside. Laplace inverse of 1 by S plus A would be what? That would be e raised to minus AT would be UT would be your response. Okay, this would be your C of T. Now let's check it out. We have to find the value of A. So two parameters are given. At a time T1, 0.63 K is there. At a 0.37 we have T2 is here. So we can substitute this value over here. So 0.37 K will be the response value when time equal to T2. K into e raised to minus A T2. And you know u of t function would be t greater than 0, that would be 1, t less than 0, that would be 0. So implicitly that is eliminated. So 0.3 K into K will be e raised to minus A T2. So K get cancels. 0.37 is equal to 1 divided by e raised to A T2. Okay. So you can write from here e raised to A T2 coming this side, that will go that side. That would be 1 divided by 0.37. Okay. 1 divided by 0.37 would be around 2.71. That means e raised to AT2 is equal to e raised to 1 you will get. Because 1 by 0.37 would be 2.71. 2.71 is nothing but what? E raised to 1. Or also we can have this technique which is called as like this. AT2 natural logarithm of E, which is equal to natural logarithm of 1 divided by 0.37. This is also will give you the exact answer. Okay. So here you will get a AT2 is equal to 1 by natural logarithm of 1 divided by 0.37 would get you 1 itself. So A value would be 1 by T2. So if you come over here, then AT2 equal to 1. So value of A would be 1 by T2 would be the corresponding answer. Okay. So time constant A would be 1 by T2. So option D is correct answer. Similarly, you can substitute this value. So the corresponding value will be accordingly, but that is exactly for a decaying curve. This would be one time constant. So you will get as exactly like this value. Is that clear? Okay. Next, first order control system initially at 0 volt and subjected to a sudden input at t equal to 0, which means that it is a unit impulse function. The output reaches 1.1 volt in 4 seconds and eventually reaches steady state of 2 volt. Okay. Then find the time constant. So it says control system initially at 0 volt and subjected to sudden input. As a result, it is reaching 1.1 volt in 4 seconds, eventually reaches to 2 volt. Okay. So you are getting some curve like this. The final value is 2 volt and at 4 seconds it is getting, at 4 seconds you are getting 1.1 volt. Okay. This is the response it is showing. Now find the time constant. We can calculate this answer by using our generalized expression. So generalized first order system response would be, see, we don't know what would be the magnitude. So simply we cannot write 1 minus e raised to minus t by tau into u of t. We don't know the magnitude. So we have to write k into 1 minus e raised to minus t by tau or t by t into u of t. I am taking tau over here. Okay. Now, why did I take k? Because I don't know what would be the steady state value. See, steady state value is known, then you can get the magnitude. So generally you have to write this expression. Okay. Now it says it eventually reaches a steady state of 2 volt, which means that when time tends to infinity, the value of C of t become 2. That is the meaning of this statement. So when time tends to infinity, you will get it 2 equal to k into 1 minus e raised to minus infinity by tau you will get. U of t will be meaningful. Like you know that U of t graph would be 1, 0 for t greater than or equal to 0, and then for t less than 0 it would be 0. So meaning all the positive variables it will having 1. So when you multiply this parameter into 1, it will be exactly the same. So here 2 is equal to k into 1 minus e raised to minus infinity would be 1 by e raised to infinity. 1 by e raised to infinity would be infinity. 1 by infinity would be 0. So 1 minus 0, you will get k as 2. This is the first portion. Now, second portion it says, it gives an output reaches 1.1 volt in 4 seconds. So your C of t is nothing but what? 1.1 voltage in 4 seconds. Okay, at t equal to 4 seconds. So substitute in this general expression. So it gives 1.1 k we got as 2. So 2 times 1 minus e raised to minus, time is given as 4 second, time constant we have to find. Okay, into u of t, you don't need necessary, I told you it will be 1 itself. So here you will get, see, 1 divided by 1.1 by 2 would be 1 minus e raised to minus 4 by tau. Okay, so 1.1 would be how much? 0.55, right? So e raised to minus 4 by tau is equal to 1 minus 1.1 divided by will be 0.55. You have to subtract that. Now from this you can take e raised to 4 by tau, that would be 1 divided by e raised to 4 by tau, and you have to take the reciprocal. So here that would be 1 divided by 1 minus 0.55. Okay, now we have 4 by tau into natural logarithm of e is equal to natural logarithm of 1 divided by 1 minus 0.55. This question has been framed in gate question where you can have calculator. So if you solve this with this, you will get a time constant would be equal to 5 seconds. You can solve by your own because you got the way how to solve it. Is that clear for you? Okay. Next question. A unit step is applied at t equal to 0 to a first order system without time delay. The response has a value of 1.264 unit at t equal to 10 minutes. Okay, 10 minutes. And 2 units at steady state. The transfer function of the system is, it is given as 10 minutes. Okay, that is the key. We cannot calculate in time in minutes. We have to convert it back into seconds. Then only we can solve it. So general expression would be first order, right? A unit step applied to a standard first order system. Okay, and it is having 2 units at steady state also. So general expression, you know that C of t is equal to, starting with the general expression, that is C of t is equal to k into 1 minus e raised to t by tau. Okay, into u of t is there, I am not taking that. Okay, now from the first information you can get it is having 2 units at the steady state, means k equal to 2. It is proven. Now the response has a value of 1.24 units, which means that 1.264 equal to 2 times 1 minus e raised to minus 10 minutes means 600 seconds. 600 divided by time constant. Okay, now this would be your expression, and you can take this left side. So 1.264 divided by 2 into 1 minus e raised to minus 600 tau. Okay, now e raised to minus 600 by tau is equal to, this term goes there, that is 1 minus 1.64 by 2. I don't have calculator, that's why I cannot do it. Okay, so you will get a 0.6 some value, and when you subtract with 1 you will get some value around 0.4 something. Okay, then if you take e raised to minus 600 by t, which means that you have to take 1 by e raised to 600 by t. So here also you have to take the reciprocal, then you have to apply the natural logarithm, then you will get the value of tau. So here you will get the value of tau exactly as 600 seconds itself. So now we can write the transfer function. The transfer function would be generalized to format of k divided by 1 plus s tau. K value you got as 2, 1 plus tau value you got as 600 into s. 2 divided by 1 plus 600 s would be the answer, which is the option D. 2 divided by 1 plus 600 s, because tau would be 600 and k would be 2. This will be the standard transfer function for this expression. Okay, if it is 1 by 1 plus s tau, then it would be 1 minus e raised to t by tau. If it is k is there, then you can add that k in the transfer function also, because that would be a constant parameter. Is that clear? Next question. If a first order system and its time response to a unit step are as shown below, the gain k is. Okay, so we have to find the magnitude of gain k. For that, it is attaining a steady state value of 0.8. Here it is given as 0.8. Okay, so we have a first order system and its time response is to a unit step are shown below. The gain k has to be found out. So here you can have your transfer function, that is y of s divided by r of s would be your corresponding transfer function, and that if you will solve, you have open loop transfer function is nothing but what? Open loop transfer function is k divided by 1 plus s tau. I told you, if you are having a unit feedback system, the shortcut to find the closed loop transfer function is, this is assumed as a numerator of s and this is denominator of s. So CLTF would be from shortcut, numerator remains the same, denominator remains the same, and you have to add the numerator into the denominator term. So from that you can get k divided by 1 plus s tau k. If you rearrange this, you will get k divided by 1 plus k into s tau. This would be your closed loop transfer function. Okay. Now here you have your r of s. What would be the input? It is unit step. So r of t is nothing but what? U of t itself. So r of s would be 1 by s itself. Okay. So y of s would be nothing but what? K divided by 1 plus k plus s tau. Okay. Then whole bracket into 1 by s. Okay. Now you have to take the inverse Laplace transform in order to find the magnitude of y of t. This would be your y of t curve with respect to t. So you have to take the inverse Laplace transform. Okay. So y of t is nothing but what? You have to take the partial fraction. So partial fraction is nothing but what? We have to convert. First, I am not writing y of t here. Let me write y of s first. A by s plus b divided by 1 plus k plus s by s tau. Okay. This is the format. Now you have to find the value of a first. A is nothing but what? At s equal to 0, you have to hide s term. Then what will be there? K divided by 1 plus k into s tau. So a you will get as k divided by 1 plus k will be your a term. It is a constant term, so you don't need to take care of it. It would be there in the Laplace transform. Okay. Now you have to find the value of b. So here I'll write with color change. B you will have, in order to find b, what you have to substitute? You have to substitute, see, here 1 plus k plus s tau equal to 0, s tau equal to minus of 1 plus k. So s is equal to minus of 1 plus k divided by tau. You have to substitute in this expression. Okay. So that would be, you have to hide this term also. So only k by s would be remaining. Okay. Now what you have to substitute? S equal to minus of 1 plus k divided by tau you have to substitute. Okay, so the answer would be B would be looking like minus of S you have to substitute that term. So here you will have k on the numerator divided by S is minus 1 plus k. This tau goes to the numerator. So B will be nothing but what? B will be kt divided by minus kt divided by 1 plus k you will get. Okay. Now you can find the value using A and B. So A you got k divided by 1 plus k and B you got minus kt divided by 1 plus k. Okay. So I'm going to clear that. Then you have to find the Laplace inverse of this particular term. Okay. So for that, let me rewrite this concept again. Minus kt divided by 1 plus k, and you can have k is k divided by 1 plus k. Okay. So let me erase it. A I got k divided by 1 plus k. B I got minus kt divided by 1 plus k. Clear? So you will get A by S plus B by 1 plus k tau s. Okay, this was the case, and you can find y of t right now. Y of t would be A is nothing but what? Let me change the color. A is k divided by 1 plus k, then 1 by s would be u of t. Okay, now to do this, what you have to do? B value substitute here, minus k tau divided by 1 plus k whole divided by 1 plus k plus s tau, but that is not in the standard format. You have to take the tau outside. Then only you will get S plus format. So if you take tau outside, you will get S over here. Then here you will get what? 1 plus k divided by tau you will get over here. Okay. Then only you can write in terms of the parameter. Okay. So if you rewrite this concept, so that we will get this tau get cancels. Now what would be the magnitude? You will get minus of constant value as k divided by 1 plus k is the constant term. You take it outside. 1 divided by s plus 1 by k divided by tau you will get. That would be nothing but what? E raised to minus 1 plus k by tau into t. U of t will be the corresponding y of t. Now it says at final value, it says when time tends to infinity, your y of t is nothing but what? Y of t is 0.8. Okay. So you have to substitute this. 0.8 is equal to k divided by 1 plus k. U of t will be 1 and minus k divided by 1 plus k e raised to, when time tends to infinity, this parameter would be minus infinity divided by tau. 1 by e raised to minus infinity, this term would be 0. Clear now? This term would be 0. So this would be e raised to minus infinity by tau would be k divided by 1 plus k into 1 divided by e raised to infinity by tau. E raised to infinity is infinity. 1 by infinity will be 0. The second term will be vanishes. Now you have here 1 plus k multiplied by 0.8 is equal to k. Okay. So here you will get 0.8 plus k into 0.8 is equal to k. Then 0.8 let it be here. Then k goes there, which means that 0.2k you will get. K minus 0.8k will be 0.2k. So k value you get as 8 by 2 or 0.8 by 2. So which means that k equal to 4. So the gain k would be how much you will get? You will get as k equal to 4. So this is how you solve it. It is a time-taking question. It may be asked for GATE 2-mark question. Okay. So sometimes it may take time. So you have to be careful. I have took around 3 to 4 minutes. So you should not be taking such a long period of time for solving a particular question. So here you got the answer as k equal to 4. So this is how you have to solve the questions which is related with the step response or impulse response of a first order system. You have to standardize it. Then using steady state value, you will get the value of gain k. And apply it. Time t tends to infinity, what would be the value? Like that you have to apply. For one time constant, what would be the value? In similar fashion, you have to use the clues effectively so that you can use the answer conveniently. Did you get my point? So this is how you have to solve the problems associated with the time response analysis of a first order system. We have done different varieties. Okay, different varieties means all the concept has to be revised when you solve a particular problem. I have taken such important problems in order to understand the concepts deeply. Hope you understood the concept I have explained in the problem session today. Thank you so much for watching it.